Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by KubeCon, Cloud Native Con, and you are invited to attend this flagship conference from the Cloud Native Computing Foundation, KubeCon, Cloud Native Con North America 2019. That is a mouthful and an awesome conference to attend. It's happening November 18th to the 21st in San Diego, California. This conference gathers adopters and technologists from leading open source and cloud native communities. Use the code KCNA Changelog 19. Once again, KCNA Changelog 19 to get 10% off registration, or check the show notes for a special link to register and also a link to the Convince Your Boss letter. Again, check the show notes for links to learn more and register.
Welcome back, everyone. This is the Changelog, a podcast featuring the hackers, the leaders, and the innovators of software development. I'm Adam Stacoviak, editor-in-chief here at Changelog. On today's show, we're talking with Chris Anderson, former editor-in-chief of Wired and a true pioneer in the world of drones. We talk with Chris about his hobby gone wrong, how he started 3D Robotics, DIY drones, and Dronecode. And we also talked to him about his newest passion, DIY Robocars.
So Chris, we have lots of stuff that we could talk with you about. Of course, your history at Wired, all the stuff you're doing with drones. We want to focus in on the drones. I read in your Amazon bio that you said you have a hobby gone wrong.
I have an Amazon bio.
You do, on your author page.
I had no idea.
Yeah, it's a little bit outdated because it still calls you the editor of Wired. So it's outdated, but it does say you have a hobby gone wrong with aerial robotics and with 3D Robotics, a company you co-founded kind of based on a hobby gone wrong. So I'm curious what went wrong and if you could tell us that story.
Yeah, so I've described drones or 3DR as a hobby gone wrong. And what I meant by that is that the hobby was super fun, took off, became kind of a movement, and became a company, at which point it stopped being a hobby. So if you're doing something for fun, and it succeeds wildly, typically it's not fun anymore. You're spending all your time dealing with customer support, community management, then it's a company. And I don't think I have flown a drone in the last year.
Bummer. I don't know.
Yeah.
A sad ending to your amazing story. Well, tell us about the beginning of this. Back when it was fun. Go back to the fun days. I think it was.
By the way, I still have fun doing other things, and it is a perfectly natural, progression. And we'll get into this probably later in the conversation. But because I miss the days of it being a hobby and fun, I decided to restart the whole thing with cars, not drones. And so today DIY Robocars is our autonomous car racing league, is super fun. And remind me not to turn it into a company.
I was going to say, when are you going to transition that into a money-making organism?
I think that you and my wife are assigned to the task of answering that as never.
As never.
Yeah, so you were saying to talk about the transition from
yeah, we'll go back to the fun days. Tell us how this thing got started. I know a little bit of the story because I got to hear some of this.
Can you share a little bit of the backstory, Jared, there? Like what interests you in Chris? The open source summit conference, maybe a little bit of the backstory?
Yeah, so we were at the Open Core Summit, and Chris had a talk about drones and robotics. I think it was called How I Convinced the Pentagon to Use Open Source Drones. I mean, who wouldn't be interested in that, right? So I was all in on that talk and got to have about an hour of Chris's time just telling us this amazing story, and I wanted more people to hear the story, and so I emailed him and said, come on and tell us. So I think it started around the time of the iPhone, if I recall.
It did. It's 2007. At the time, I'm editor of Wired. I've got 5 kids. And my wife and I are scientists by training, and we're always trying to get the kids interested in science and technology. And we bring home projects, and they would invariably be disappointed and tell us that we're nerds, which is true. And this particular weekend, like early 2007, 2 things came into the office at Wired for review. One of them was a Lego Mindstorms NXT kit, which is the robotics kit. and another was like a radio control plane. And we had a deal at Wired, which is you were allowed to take a review thing home on the weekend as long as you agreed to review it. So typically, first come, first serve. I grabbed these two, and I said, okay, kids, on Saturday, we're going to build a robot. And on Sunday, we're going to fly a plane. And they're like, okay, we'll see. So on Saturday, we diligently followed the instructions. And when you build a Lego robot, it's got, wheels and it's sensors, and it takes all morning to put it together and to program it. And then it sort of very slowly, moves forward until it sees a wall and then sort of moves back. And they're like, that's stupid. We've seen Transformers, right? Where are the freaking lasers?
Boring.
Boring.
Lasers.
Yeah, exactly. And I was like, okay, fine, I get it. A little dull. By the way, Hollywood has ruined robotics for kids because you just can't compete with CG.
Good point.
So then so I'm like, okay, tomorrow, Sunday, we're going to fly a plane. And so we look on YouTube, we see the videos of acrobatics and cool stuff, and they go to the field, the park with me, and I launch the plane and it immediately flies into a tree, and they're like, that also sucked, and I kind of had to agree with them on both counts, and so I come back and I had to bribe them with ice cream, and I come back and I thought, how could that have gone better? Clearly we needed a cooler robot and a better flying plane. And I thought, well, what if the robot was the plane? What if it would just fly itself? That would be cooler. And so I Googled flying robot. And if you Google flying robot, it turns out that you get drone. That's what a drone is. It's a flying robot. I'm like, got it. Huh. What's a drone? If you Google drone, it's an aircraft with an autopilot, like a plane with a brain. Mm-hmm. I'm like, yeah, okay. Wait, what's an autopilot? If you Google autopilot, it's like sensors and compute and software. And I'm like, that's kind of what's in the Lego Mindstorms box. It came with gyroscopic sensors, accelerometers, magnetometers, a Bluetooth connection, which would connect to GPS. And I'm like, I think it's kind of the same stuff that's in this box. And so we, around the dining room table, we stuck together the bits and had a 9-year-old program the code. And we had a Lego autopilot. And then we stuck it in the plane, now retrieved from the tree. And the next weekend we went out, and it worked. Not brilliantly well,
sure.
But it flew,
Proof
and
of
it flew
concept.
by itself. Yeah,
Any
exactly.
lasers this time?
No lasers. Still no lasers. So they were
We'll get to the lasers.
They were interested for 10 more seconds, and that was it for them. And I was like, what just happened? Right? That should not be possible because at the time drones were like Predators and Global Hawks and military industrial, and they were classified and super, $10 billion things. And we had just built a drone with Lego pieces around the dining room table programmed by a 9-year-old. And it's like, okay, putting aside that it's not a brilliant, great drone, that should not be possible. Mm-hmm. When a 9-year-old can do something that is classified, that literally export control it as munition with Lego, with toy pieces, something important in this world has changed. And I wasn't clear what it was, but I knew it was something. So I set up a website, and 10 years earlier it would have been a blog, and 10 years later it would have been a Twitter feed. But at the moment it was a social network. So I set up a social network called DIY Drones, and it was largely so I could chronicle, my own experiments, but also kind of ask dumb questions. Learn, exactly. And it just so happened that my discovery at that moment had kind of coincided with a lot of other people who were discovering the same thing, which is that this sort of impossible thing had suddenly become easy. And some people had come via, advances in radio control airplanes, with electric power and better radios. Some of them had come via sort of the maker movement with 3D printing and Arduino. Some had started playing around with the components in the iPhone, which had come out that year. Or also that also could have been found in a Wii controller, like the accelerometer.
Right.
And everybody had sort of had there was a kind of there was a glitch in the matrix. There was this sort of this disturbance in the force that had gone out in 2007. And anybody who was paying attention to hardware sort of recognized it, but everybody saw it slightly differently. Like, for example, the Fitbit founders had bought a Wii video game console, and they were looking at the controller, and they were like, "What's in here?" And it's like, "Oh, it's this like accelerometer chip. I wonder what else they could do. I could do with that." And they made the Fitbit. And so everyone was kind of recognizing there was this bounty of like cool stuff that, in retrospect, we now call the peace dividend of the smartphone wars. But that basically the components of smartphones and the economies of scale of the Apples and the Googles of the world, with MEMS sensors, Wi-Fi, battery technology, GPS technology, radio technology, all these bits had transformative effect in adjacent industries. And it was up to us to figure out how to take these bits and use them elsewhere. And my elsewhere happened to be drones. But you could see this explosion in hardware innovation around there as everyone figured out some adjacent space to explore.
So yours was drones and hobby at this phase. Tell us the next step in your process. You have a website, DIY Drones. I think at this point it's growing maybe faster than you expected because, like you said, it was kind of a moment in time. Was that a strong indicator for you? Like, holy cow, there's something here and I need to keep going? Or were you just continuing to tinker?
I was continuing to tinker, and the very first autopilot was the very first 3 autopilots were ones that I had programmed, which I'm not a great developer, so that tells you kind of what level they were at. But 2 things happened that sort of tipped me off. This is bigger. Number one is that people started contributing their own better code and electrical and electronics designs. So that was good. And then teams started to form. People started to work with each other. So, the way open source always works in my experience is that, you do something to scratch your own itch and you put it out there. And it might inspire other people to do their own thing. And then at some point, they start to clump. And people say, rather than doing my own thing, I think I'm going to join up on your thing, or I'm going to do a pull request or a bug fix or an issue report. The moment they start working together, then you've got something. And so what we saw is that phase. I'm putting out kind of stuff. It's it's like our Lego Autopilot made this back in the day. It made the front page of Slashdot. Okay, so that was a thing back then.
Sure.
And then everyone's like, "Oh, that's super cool," but your code sucks, which is true. It was written by a 9-year-old. And by the way, that Lego drone is in the Lego Museum in Billund, Denmark right now.
What?
It's the world's first.
Awesome.
Yeah.
Awesome. So did Lego? Did they receive it? Did they care about it? Did they?
Oh, they loved it. I mean, I was the editor wired, so it was kind of cool marketing for them. But yeah, so I was also on the advisory board for Lego Mindstorms later. So it all played well. By the way, a cool little bit about this. At the time, and actually still, autopilots were considered cruise missile controllers and a weapon, or munition, to use the phrase. And so they were export controlled. And if you export the technology for a cruise missile controller, you can go to Guantanamo Bay. I mean, it's like super bad.
That's bad.
And the act of putting something on the internet is considering exporting it. Now, so technically we weaponized Lego.
You're on shaky ground there.
And I was just like, please subpoena my children so that they have to testify in Congress about how they put a Lego Autopilot on the internet and committed some sort of grave crime.
Best press of all time, wouldn't it be?
Yeah, you really can't do better than that. They sadly, wiser minds realized that the problem was not us, it was the law.
Right. When did the law change around that? At what point did they get wiser to it?
The law never changed. There are 2 things that the law accommodates. One is that there was an exemption for public domain. So if you open source the stuff, then it's considered public domain, and you're no longer, you're exempted. So on the assumption that no one would ever open source a cruise missile controller, but of course that's kind of what we did.
Apparently, that's a bad assumption.
Yeah, it's a bad assumption. And then the second exemption is that over time, the definition of military-grade technology keeps evolving as technology evolves. So remember, like back in the day, like a PlayStation 2 was considered export controlled because you could be designing nuclear weapons on it or something like that. Mm-hmm. And so over time, as things become commercially available and sort of off the shelf, they fall off the list of munitions. Now it took. I should tell you that it took to 2013 before the autopilot that my children made fell off the list. Oh, that quality of autopilot fell off the list. And it was only once you could literally buy it in like Walmart was it considered no longer eligible. And it's a constant struggle to educate the regulators that, hey, you know what, GPS is like in our phone. And they're like, huh. Okay, but what kind of GPS? And is it GPS as a standalone module? Is that still, export control? Anyway, it's a long struggle, and I'm glad I'm not doing that anymore. But yeah, that's how we got around.
Did you actually have lots of meetings with them where you have to go in and explain these things? Because there is this, like, you have the commoditization of all of these different parts. Like you said, there's this moment, and then you have this ragtag team of open source people putting out into the world the plans for building defense mechanisms, right? And you have, meanwhile, you have like this huge industry of $1 million, million is a small number, multi-million-dollar service contracts and like all these things, and it's just going by. It's going to quickly go by the wayside. Yeah.
So there's logic. So what you just said is very logical.
Thank you.
The way it actually works is that you have inspectors at the kind of ground level, and their job is just to implement the laws as they understand them. So did we have lots of meetings? Yes. Did the FBI, come to the office? Many times. And everybody was, I was going to say everyone was super nice. That isn't actually true. The FBI was super nice.
Most people. Who wasn't very nice?
The Export Control Administration is handled by the Department of Commerce. And they have these kind of regional inspectors. And the regional inspectors have quotas of like how many people do they put behind bars today. And they didn't want to hear the logic. They're just like, it looks to me like you're violating part whatever. Right. Prove to me that you're not. And it's just years of lawyers to just to kind of like literally you just have to show them that this can be bought in Walmart.
Right.
And then you'd need to, prove that it's the same as the one you're doing right now. And it's just, unfortunately, as a pioneer, we are the ones who had to go through it first.
This episode is brought to you by DigitalOcean. Guess what? DigitalOcean recently added MySQL and Redis to their list of managed databases. Their full managed databases lineup now includes the 3 most popular databases out there for developers: Postgres, MySQL, and Redis. It'll eliminate the complexity involved in managing, scaling, and securing your database infrastructure, and instead get back to focusing on building value for your users. Learn more and get started for free with a $50 credit at do.co/changelog. Again, do.co/changelog.
So while you're pioneering this and you're taking lots of meetings with scary people, sometimes nice, sometimes not so nice people, you're also at the same time this open source, this forum and this open source code. You're starting to build a hardware company, 3D Robotics. Tell the story of how that actually turned into a business. I know you have a co-founder, which is a very interesting tale.
Yeah.
Unpack that for us.
Yeah. We start that with the community. The community starts taking off. People are sharing code and design files, and it's pretty exciting. It's clear we're doing something, and it's accelerating really fast. It's still very much a kind of a hacker thing, but the word's getting out. This is now possible. And then the next generation of people come and they're like, hey, we heard that you can there's a thing called, you can put the letters DIY in front of a drone. I would totally like to have my own drone, but I don't know how to program. I don't know how to fab a PCB. I don't know how to solder. I don't know, how to compile, whatever. Can you just do it for me? Can we buy one, or a kit or something like that? And so we said, well, I guess we need to turn it into a kit. And we started really simple with an autonomous blimp called Blimpduino because it used the Arduino.
Nice.
And it was my kids assembled it on the dining room table in pizza boxes. We made 1,000 of them for a maker fair. They sold out on Saturday. I came home and I said to the kids, "It's great news. Everyone loves our blimp kit." And they sold out, and they're like, whatever.
They have no.
Your kids are just completely nonplussed by this entire.
These are Silicon Valley kids, right?
Okay.
It's impossible to impress them. Someday they'll thank me. And I said, well, we need to make more. And they're like, not going to happen. We're not doing that again.
We're out.
We're out. So I went onto the forums, and there was this like, I was like, I need someone to help, put together these kits. And the smartest guy in the forums was this guy who was flying a remote control helicopter with a Wii controller. And he posted the code and the YouTube videos, and it was really good. And his name is Jordi Munoz. Never met him, just a guy on the forum.
Yeah.
And he said that he had a little spare time, and that he would be happy to help me. So I said, "What do you need?" And he said, "I need $500 for parts." So I sent him a check, literally a check in an envelope, for $500. And he sent me back a picture of him in the garage, soldering together the parts. And and I thought that was the end of it. They continued to be made. We set up a little e-commerce shop, and that was it. But he kept sending me more pictures, and just like, I've got some friends to help me. We've moved to a garage. We've moved to a bigger garage. No, we bought some pick and place machines,
scaling
some
operations.
reflow ovens.
He is.
And I still never met the guy at this point. And by 2012, Jordi had, with a full investment of $500. We incorporated as a company, which again I did on the internet. Never met my co-founder, no capital. By 2012, we had factories in San Diego, Tijuana, Mexico. We're the biggest drone manufacturer in America by a factor of 10, making more drones per month than all of America's aerospace companies combined. We're on a $10 million run rate, and I still hadn't met my co-founder. So I'm like, maybe it was 2011, but it was early. So I'm like, the venture capitalists are like, I'm still the editor of Wired. It's a hobby gone wrong. So the venture capitalists, who had been saying, this is kind of a thing. You should do this.
You think?
Yeah. I talked to my wife about it, and I said, I think maybe it's, media is kind of getting a tougher industry. It's still doing really well, but you could see that media was going to get tougher. I've been doing it for 12 years, running Wired.
Yeah.
And meanwhile, this sort of side project had sprouted, and I said, I think I might want to just raise capital and do it. And she says, well, you've got to raise, a lot of capital. I'm like, how much? She said, well, $1 million for every child. So we had 5 children. So I said, okay, I'll raise $5 million, which seemed like a lot at the time. Mm-hmm. So we raised $5 million. She let me quit my job. I met my co-founder. I actually met him during a part of the fundraising thing. And it turns out that Jordi, when I had actually started this, was when he started this, he was 19 years old. He'd just graduated from high school in Tijuana, Mexico. He was actually in the United States because he was having a child, and they wanted it in the U.S. and kind of working on citizenship stuff. That's why he had spare time. Mm-hmm. And, I'd accidentally created a 21st century aerospace company with a teenage, high school graduate from Tijuana who I met on the internet.
I love it.
Which is like
that almost
perfect.
never happens.
It doesn't sound right, but as I say, if you want to start Facebook, get a kid from a Harvard dorm room. You want to start a manufacturing company, get a kid from Tijuana.
Right.
That's where
competitive advantage, right?
That's the Shenzhen of North America. They just I didn't know what a pick and place machine was, and he just bought them used on eBay and downloaded the manual from the internet. I mean, wow. If you grow up in Tijuana, building electronics factories is just something people do.
Explain pick and place just quickly.
Oh yeah, so an autopilot is basically a circuit board with lots of chips on it, and a circuit board is like a fiberglass board that you just have those made, and the pick and place is a robot that takes the little chips and puts them on the board very precisely on top of a sort of a goopy gray paste, which is actually solder. And then it goes into what's called a reflow oven, and then that kind of melts the solder and all becomes electrically connected. And then there's other elements of it, but it's basically a robot that makes electronics.
Oh.
So Adam and I also met on the internet, and he had the changelog going at the time. We're business partners, but it took us years to build up trust, didn't it, Adam? I mean, anybody you meet, you have to build up trust, but especially when you meet them online. It seemed like you with Jordi, you didn't mind that much, maybe because it was a hobby. I
didn't. Yeah, trust has never been an issue for me just because I've been lucky. But I wasn't putting much at risk. It was like literally $500.
$500.
Yeah, right. $500, and I expected nothing. I literally, expected never to see it again.
Did it literally not take more than 500 to scale it to the 10 million run rate you mentioned? Like $500 in to invest.
They were cash flow positive on day one.
Wow.
I mean, we subsequently were raised, after we took venture capital, we raised like $140 million. So,
right. So eventually it grew up, but it was.
Eventually it grew up. But the first, first like 4 years of the company, no, that's not right. 2009 through 2000. Yeah, about 3 years of the company was all organic cash flow.
Who was buying the drones? DIYers?
Well, they weren't even drones at that point. They were actually kits. Yeah, they were DIYers. So the whole drone community ended up being sort of two communities that came together, but never really culturally. Some of them were just like geeks who were just fascinated by new technology, and robots and software and that kind of stuff. And that's where I came from. No interest in the flying part, just kind of like, this is like the hottest new thing. I got to understand it. The other community were like radio control hobbyists who wanted to extend their hobby with, autonomy and going, first person view and things like that. And they were really into the flying thing. So I actually have no interest in the flying thing, which is why I don't fly drones. I was really interested in the software and the hardware and the data that drones could acquire. And so basically you have pilots and programmers. And the pilots would go out in the field and they really liked, the airtime. And the programmers sometimes never even flew. And so we had these two communities come together. And today, you still see the schism in the drone world between pilots and programmers. Programmers are about autonomy. These are robots. They should not have humans involved.
And pilots want to fly them.
And pilots want to fly. So basically we banned, but I have a kind of policies, no sticks. If there are sticks are like the remote control sticks. If there are sticks involved, it's not a drone. And we actually unscrew the sticks because we still use for FAA compliance purposes. There still needs to be ability for a human to take over, but we actually unscrew the sticks. So just so that no one accidentally touches them. So I believe that that humans should not be flying. I think whoever the Wright brothers skeptics were right that humans were not meant to fly. They're meant to be flown, but not to fly. So I'm 100% autonomy, and the pilots, still really like the human centrism of the whole thing. And today, in the industry, the pilots are called operators, and the programmers are called developers, and they're still kind of in opposition to each other. And over time, as long as the FAA requires a so-called pilot in command, the operators still have to be there, but they're not. There's nothing left for them to do.
Yeah,
they're literally just standing there as a kind of a statue of compliance. But we don't want them touching the sticks. It's like if you fly a jetliner, across the country, your pilot's not doing anything. I mean, that, right?
For
they
sure.
are just in the cockpit. Two of them are in the cockpit, just in case. And maybe
There's a social
today,
factor there as well, right? Like they
yeah. I call it like flight theater. It's like they wear a uniform, they've got a hat, they talk to you over it's all theater.
Somebody has to make the announcement how many people are flying at, and everything's going to be just fine, folks. Everything's going to be just fine.
Exactly. Now they'll still do the takeoff and landing because pilots actually you could tell the difference between an autonomous landing and a manual landing.
How so?
The smooth ones that you applaud, the pilot had nothing to do with that. That was all the autopilot. The bumpy ones, that was the pilot.
Okay.
Wow.
That's not fair, by the way. But these days, like a new Airbus can take off and land and even taxi by itself.
So slightly upstream, but are you bullish on the autonomous cars then in terms of like fourth level self-driving? What are your thoughts on that in terms of autonomy?
Level 4, yeah. So as my hobby is on the side now is that we do autonomous car racing. And these are sort of subscale, so they're like 1/10 scale. The same technology, same software, same LiDAR and cameras and other sensors. Just smaller scale, which means that we can do them indoors, that nobody gets hurt. They cost less than $400. And we can race, wheel to wheel, two cars on the track at the same time. Super cool.
No sticks.
Really fast. No sticks. They're literally, they're not. You get disqualified if you touch a stick. So we're doing level 4 autonomy every day in our races. That said, they crash all the time. It is all about the crashes. It is freaking demolition derby.
So what is it that makes the difference between a team then? Is it the ability to program, the ability to fine-tune the different components to...
All of the above. We basically don't want it to be about the car. So a lot of people are like, I'm going to have bigger motor or better tires. Right. And we're like, that's kind of not the point. So we actually have kind of basically 4 different classes of cars. I mean, there's 2 distinct classes that are small and large, but within those classes we have 4 different technological threads. One of them is computer vision, and that's sort of the Tesla. That's standing in for Tesla. So it's all a proxy war, right? So we're basically doing the Tesla versus Waymo everything.
It's all a proxy war. Love it.
So the computer vision teams are sort of standing in for Tesla, and then there's the deep learning teams. It's not a perfect analogy since Tesla uses some deep learning as well, but you have computer vision teams that are kind of classic computer vision, and then deep learning teams fall into 3 classes. There's reinforcement learning, which is the Amazon, approach where you sort of give it sort of goals and rewards and cost functions and things like that. There's a behavioral cloning team where you drive around manually a few times and it sort of sees the correlation between what the camera sees and what your input was, and it learns from that. And then there's a simple supervision team, which is the NVIDIA team. And when I say NVIDIA team, I mean based on the NVIDIA technology,
right.
Jetson Nano and all that. And that team and that approach is that basically you just sort of show it, 100 or 200 photos, and you click on where you would drive, if you were seeing that, right. and it learns from that. And there's also things involving LiDAR and SLAM and fisheye lenses that are looking at the ceiling patterns and lights and all sorts of clever techniques. But it's basically algorithmic approaches versus other algorithms.
Is there anybody any methodology that's pulling away from the pack that's proving to be more reliable?
Some of the custom ones. So you can actually see the data we posted. They just beat the fastest human. Which is saying something. I would say that some of the custom approaches that are really optimized for this course were indoors at a place called Circuit Launch in Oakland. By the way, there's hundreds of these communities around the world now, and about 10,000 people. But the main one is in Oakland, California. One clever approach recognizes that the lights on the ceiling of this place are kind of a distinct pattern. And so it localizes, it's got a fisheye lens, and it can sort of see the entire room from above. And one of the problems is when you're looking forward or around you on ground level, it's it's crowded. There's spectators on the side, other cars, etc. If you look up, on the ceiling, it's clean, and so it localizes itself based on that. And that one's really fast. There's another one that's doing the same thing, but we have cones on the kind of the key corners, and it localizes itself by spotting the cones with LiDAR. So those are the ones that are super optimized for this course, and they're the fastest. They're not generalizable. Obviously, if you're looking at ceiling lights, it's not going to work outdoors. Yeah. So those are not generalizable approaches. But anyway, there's the answer.
Okay, so to summarize on the feasibility of level 4 in the real world, are you bullish on that?
Not in the near term, no. I'm and by the way, we're dealing with the same thing with drones. They're not fully autonomous for a couple of reasons. One, the main reason is regulation. They're not allowed. So the only way we get efficiencies is when you break the 1-to-1 human robot ratio. If there's still, it's like your autopilot on your 777 is not achieving anything in terms of efficiency because you still have 2 pilots, sitting out. Now it may make their life easier. It may be safer. If the payload is a
human, if the payload's not a human, then you do have some efficiencies there, right?
Right, but in our case, although the payload's not a human, there still has to be a human present, standing on the ground doing nothing. So we haven't actually achieved any kind of labor efficiency. And the reason we haven't is, again, the FAA regulations have limited us in that respect because of the kind of pilot and command concept. We're about to break through that, and there's a principle called type certification. If an aircraft is tested and considered safe by the FAA, it's allowed to do riskier things. No drone to date, I think possibly one military exception, but no drone to commercial drone to date has been type certified. And we're going to have the first one in about a month's time. And this has to do with the recognition that drones are a low risk kind of aircraft. And that as aircraft have moved from a mechanical era in the 50s to essentially software era, the process of regulation has not kept up. And the 737 MAX crisis is a perfect example of an outdated regulatory system that basically locked the software down in 1967 when the 737, and all the software additions since then have been patches on top of the core. So it's like COBOL, in the government. And because it's too hard to recertify, because they basically say, we're going to look at every line of code, and you can't change the code, or you have to recertify. It was very hard to improve the code.
Yeah, it's like legacy code by way of dictate. Like you have to keep
exactly. So I think everyone recognized that back in the day when code was a tiny fraction of the vehicle, that was okay, but now as the majority of the vehicle's technology, it's not okay anymore. So rather than just sort of swap to this new approach where it's like, hey, we're going to treat a phone like a plane like a phone. So Verizon doesn't look at every line of code in Android. They say, look, you guys do your job, build Android the way you think you should, and we're going to test it on our networks, and we're going to look at its performance. And we have a battery of tests, and if it performs well, fine. Update the code all you want, just don't change the performance. So the FAA is going to be doing the same thing with drones, and it's called performance-based certification. And what they're saying is like, you tell us how it performs, we test to make sure it really does perform that way, and you can continue to improve and fix the code as long as it doesn't change these key performance criteria. Now, this is super good. It's a 90-day process rather than like a 9-year process. It's built on our code process, which after we got into hardware, we built a ton of drones, then we got out because the Chinese were doing such a good job. We put the code into the Linux Foundation as something called Dronecode. And it is today the sort of the Android of the space. It runs a code stack called PX4. And so that the way we develop that code and the professionalism of that consortium and our testing and a simulation process is now becoming the standard that the FAA is adopting, and that's great. They want to do this experiment at the lowest risk category. So these are vehicles that weigh about 2.5 kilograms. They're flying under 400 feet. Not carrying people, and we're going to build up millions of hours of evidence that this is the right way. And as the FAA gets more and more statistical power to prove that this method works, they can expand it to larger drones flying over people, maybe air taxis, urban air mobility, and maybe a generation from now, the next generation, the next jetliners will use this certification process that had been tested on drones first.
This episode is brought to you by KubeCon, Cloud Native Con, and you are invited to attend this flagship conference from the Cloud Native Computing Foundation, KubeCon, Cloud Native Con North America 2019. That is a mouthful and an awesome conference to attend. It's happening November 18th to the 21st in San Diego, California. This conference gathers adopters and technologists from leading open source and cloud native communities. Use the code KCNA changelog 19. Once again, KCNA changelog 19 to get 10% off registration, or check the show notes for a special link to register and also a link to the Convince Your Boss letter. Again, check the show notes for links to learn more and register. And by cross-browser testing from SmartBear, the innovator behind the tools that make it easier for you to create better software faster. If you're building a website and don't know how it's going to render across different browsers or even mobile devices, you'll want to give this tool a shot. It's the only all-in-one testing platform that lets you run automated, visual, and manual UI tests across thousands of real desktop and mobile browsers. Make sure every experience is perfect for everyone who uses your site, and it's easy and completely free to try. Check it out at crossbrowsertesting.com/changelog. Again, crossbrowsertesting.com/changelog.
Mentioned Dronecode. It's out there, Linux Foundation. We'll link it up in the show notes for everybody to go click through and check out all the different sub projects and bits and bobs. the DoD itself also seems to be adopting some of the. Is Dronecode the platform that the DoD, at least in some capacity, is interested in adopting, or they have adopted?
Yeah, they have adopted. DoD is giant, and there's many different parts of it. But there's one, basically at the small drone size, they can go to Walmart and they can see what you can get from DJI, but they're not allowed to use DJI because Chinese and all that kind of stuff. So they want basically. And this is a case throughout the military. They want what's called dual use technologies. They want to get the I was going to say bang for buck, but that's probably not. Maybe that's too on the nose for DoD. But they want the same price performance as consumer technology, but they want it to be more secure. So rather than just buying Chinese drones and using them, they want to work with a open platform that can create drones as good and as cheap as the Chinese ones, but is trusted because they, at least parts of the DoD now recognize that open source is verifiable. It performs well. They kind of Linux has correctly evangelized that open source is a good thing. Yeah. And so they've realized that the way they're going to get price for performance is with an open platform, and not only because it can be trusted and verified and checked, and they know and they know where it comes from, but also it avoids vendor lock-in. An open platform means that they can get many different companies using this standard, and because they hate vendor lock-in, because vendor lock-in, it's called a program of record, and once you have a program of record, it's a monopoly. And by dictating open standards, they're essentially dictating competition. And so they've adopted elements of the Dronecode stack. There's a communications layer called Mavlink. There's a open source ground station called Q Ground Control. And then there's the underlying code called PX4. And there's an entity in the Bay Area, Silicon Valley area, called the Defense Innovation Unit. And they've been sort of tasked with stimulating this kind of open ecosystem for defense needs, and they're the ones who have mandated this code base.
So where does 3D robotics fit into this new matured world where there's an open platform? Are you just one vendor amongst many, or do you guys still have something that sets you apart?
Yeah. Well, so we sort of accidentally got into hardware, then accidentally got into hardware, well, then purposely got into hardware really big, we went. Back in those days, in like the 2013-14, only consumer use of drones was allowed, so recreational use, but commercial use was not allowed. So we had to go consumer, and it was hard. You're talking Best Buy, hundreds of
small margins.
Small margins, a lot of price competition, a lot of risk. We made, a couple 100,000 of these things. The Chinese did it better than us. That just for economics, their economics were better, the scale was better, et cetera. They were really innovating brilliantly, and they just beat us. So we got out of consumer, and just as we were doing so, the FAA allowed commercial. So we're like, look, it's like, why don't we make cell phones in America today? And the answer is China does a really good job of it. So instead we make cell phone software. And so that's what we did. We said, look, the drones exist. The only reason we did hardware and software is because we needed to make a vertically integrated instantiation of a drone that worked. Once you could do that, once somebody else is making the hardware that's good, and you can just focus on the software side, and the experience is still good. So we moved into software. We focused on the data, construction, geospatial, and today we're a big company in that space. And that would have been the end of it. We went from the kind of DIY phase, the sort of the components, to the full drones, to just the software. Now we're a SaaS company. SaaS is good business. It's better margins, all good. And that would have been the end of it were it not for this current freak out about China, the Huawei, stuff and all that. And, what happened is that the U.S. government essentially banned the purchase of DJI vehicles. It's a kind of a soft ban, but it's pretty clear the way the writing's done. DOD made a hard ban. The Pentagon made a hard ban. And then everybody said, the government's like essentially shut down, which is really bad because, among the things that they were doing is they're fighting forest fires. The Department of Interior is fighting the forest fires in the Pacific, West, California primarily, and they use drones, for that to spot, look through the smoke, spot hot spots, things like that. And they were at risk of having this important program shut down, public safety, fire, police. It was basically a problem. The fleets got grounded. And so we realized that this was kind of the best thing for Dronecode is that Android would only succeeded because Google was there to stick it in hardware and get it out there. Before that, it just didn't have critical mass. We don't have a Google for Dronecode, but what we do have now is a market. There's a vacuum in the market where DJI is not allowed to participate, and there was demand for an open alternative. And so the question is, who's going to turn that into hardware? And we did not want to get into the full hardware business at all, but we did see that there was demand for it. So what we did is we took one of our Chinese members of Dronecode, a company called Unique out of Shanghai, and we commissioned a custom vehicle from them that was going to run. They were already using the Dronecode software, but we commissioned one that was appropriate for government use, and then we have them ship it over in an incomplete stage. So with the commodity elements, the motors and the batteries. And then we assemble it, we provision it with software in the United States. We add, we basically test it. And that hybrid of sort of, Chinese commodity hardware, then, American software, and ultimately cameras and autopilots, et cetera. So the smart stuff being made in the United States and the commodity stuff being made outside the United States, built around an open platform. That hybrid approach is what we're promoting. And, right now, some parts of the government like it. Other parts of the government say, did that atom touch China? No atom that touched China shall ever touch us.
Right.
We're right in the middle of this, silly political battle. But we think we're on the right side of it. And we think that the hybrid approach is the way that we handle the geopolitical wars of the future. And, check back in a year or two and you'll find out whether we're right.
Well, if you get the components from China or assemble them yourselves and you're controlling all the software, you kind of control the security, I suppose, except for maybe potentially sneaky software hanging out somewhere. But, again, if you kind of control the components you're putting together, you have a control of the rough security of things.
I think so too.
Yeah.
There was a Business Week cover a year ago that got turned into, it's called Chipgate, where there was this allegation that circuit boards from China had like a component that was not specified on the board, and that component was like a backdoor, sneaky, whatever thing. I don't think first of all, it's certainly possible. I don't think that particular story was true. I think it sort of played to the paranoia of those who wanted it to be true. But now there is a contingent within the U.S. government who basically says that no circuit boards can touch China. Now, that's fine. We can make circuit boards in the United States. If you tell me that no plastics can touch China, no batteries can touch China, no wires can touch China, then I think we're in silly territory, and you might as well just pay Lockheed Martin $1 million and do it the old-fashioned way.
Yeah.
But we're trying to find out where that line is, and right now there's a bill actually in Congress that defines the line as the autopilot, the radio, the camera, and the gimbal. If those parts, and by the way, and all the software that goes into them, if those parts are made in the United States, everything else can be made elsewhere. And I think that's appropriate.
Awesome, Chris. Well, we're running out of time here. Tell us real quick on your new hobby, DIY Robocars. For folks interested, where's the place to go? You said there's a meetup in Oakland. What's the waypoint?
For sure. Yeah, so we have a site at DIYRobocars.com. What you'll see is there's links to all the local meetups. There's meetups around the world. I guess we have about almost 100 at this point. In Europe, I think this last weekend there was a meetup in Stuttgart and one in Helsinki. There was one in Cambridge, in the UK, etc. So there's a list of local meetups. There's a number of projects that you can use to get started. One of the popular ones is called Donkey Car. And I think if you go to donkeycar.com. There is Amazon has just released, or I think it's not clear whether Amazon's released it. I'm going to check this is going to be a real live check. Amazon announced something called Deep Racer, which is their autonomous car, and they announced it earlier this year, and it's been delayed and delayed and delayed. And I'm going to right now find out in real time whether it's shipped today as it was meant to. And the answer is
Pins and needles.
Pins and needles, and the answer is track package. It has not shipped.
Oh.
It is not shipped. So we're all, it's showing as like now arriving Tuesday, but it has not crossed the ship line, and we're now sort of like slightly afraid it's going to get delayed till next year. NVIDIA has a number of racers. One's called Jet Racer and one's called JetBot. So these use the new NVIDIA Jetson, which is really cool. And there will be more, but go to DIY Robocars and they're all linked there.
I love the tagline you have there: fast, cheap, out of control.
Yeah.
Just love that.
I think they're all equally important. Fast and expensive, not the point.
Right.
Slow and expensive, not the point.
No fun.
In control, absolutely not the point. If you see if watch any of the videos of our races, the crashes are half the fun. And by the way, it used to be they crashed because the software sucked. Now they crash because they're going so fast and they're so competitive. They're hitting each other as they jockey for position, and they tumble and nobody's been hurt.
Good.
That's progress right there.
We'll have to have you back on, Chris. We could talk more at length at some point on, especially where this is going. It seems like we could have camped out just on DIY Robocars alone and had
Chris
a lot of
might
fun.
have preferred it. It seems like you get real lit up when we talk about that.
I know. Well, it's because it's the hot new thing,
Yeah.
and the thing is that with drones, it was technical. We solved all the technical problems like 5 years ago, and now it's business problems. With cars, we're still right in the middle of solving technical problems. So I'm a nerd. I like solving technical problems.
Well, we really appreciate you joining us today. It was lots of fun, and thanks a lot, Chris.
Thank you.
All right, thank you for tuning into this episode of the Changelog. Hey, guess what? We have discussions on every single episode now, so head to changelog.com to discuss this episode. And if you want to help us grow this show, reach more listeners, and influence more developers, do us a favor and give us a rating or review in iTunes or Apple Podcasts. If you use Overcast, give us a star. If you tweet a link. If you make lists of your favorite podcasts, include us in it. Also, thanks to Fastly, our bandwidth partner, Rollbar, our monitoring service, and Linode, our cloud server of choice. This episode is hosted by myself, Adam Stacoviak, and Jared Santo, and our music is done by Breakmaster Cylinder. If you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go into your podcast app and search for Changelog Master. You'll find it. Thank you for tuning in this week. We'll see you again soon.